Friends, look at this photograph whose name is the pale blue dot. Now, I am sure that 90s kids must have remembered their childhood by looking at this. Now I am saying this because this photograph is so old that many of us may not have even been born then. On February 14, 1990, the Voyager 1 spacecraft pulled this photograph 600 million kilometers away from Earth. In this photograph, you can see a smaller object than a pixel. That is our Earth. And this is the only photograph taken from the farthest point of the Earth to date. Now, friends, everything in this dot is the only place of life in the universe. And we all have a home. This photograph was taken at the request of Carl Sagan in 1990. Launched on September 5, 1977, this spacecraft has now reached 2,400 million kilometers from Earth and has also become the farthest object sent by humans in space. Now, friends, this spacecraft has broken many records in its 45-year journey and has also taken many incredible photographs of outer space. But do you know why Voyager 1's cameras have been closed for the past 32 years? Now we get to see an example of this in the camera system of Voyager 1. Friends, there are two Vidicon cameras in Voyager 1, which are basically television cameras of that time. These are 800 by 800 resolution cameras that capture 8-bit images in grayscale. Now, one of these Vidicon cameras has a wide-angle lens so that full-size photographs of the planets can be taken, and the other has a narrow-angle lens so that detailed photographs of the planets can be taken by zooming towards the planets. Now, the entire optical system was installed in these cameras so that we could get colored images. Now, to do this, a rotating filter wheel was also installed outside the cameras with great skill. It had filters of orange, violet, blue and green colors. And obviously, a filter was used to take a grayscale photograph. Now, let's understand the functioning of its cameras with the help of an example. Let's assume that the Jupiter planet is visible from the front, due to which the light rays are reflected and coming towards the camera. Whenever these light rays pass through filters of different colors, they take multiple photographs of Jupiter. Now, let's assume that the light rays pass through the blue color filter. Then only the blue color will come forward and the light of the other colors will be reflected. And in this way, we get a lot of images of different filter colors. When all these images are combined together, it gives a colored image. Just like the camera system of Voyager 1, we also have 3 color filters in our eyes: red, blue, and green. You must have experienced that when we rub our eyes, we see some colored lines around the object in front. Actually, it happens because of these color filters. But in Voyager 1, the journey of light rays did not end by passing through the camera filter. In fact, there was also a Vidicon tube in these cameras. A transparent faceplate was placed in front of the Vidicon tube on which tin oxide was coated. Just behind it is a photoconductive target plate. When the light photons coming from outside collide with the target plate, free electrons are created. These free electrons go and stick to the transparent faceplate and make gaps in the target plate. In the Vidicon tube, there is a cathode gun at the back that releases the electron beam towards the target plate. This electron beam fills the gaps of the target plate. This creates a signal in the form of electric current, and the entire information of the image is stored in this signal. Now, Voyager 1 simply transmits this data to scientists sitting on Earth. But wait a second. This process is not as easy as living on Earth, where a person has to send a photo to another on WhatsApp. Actually, every photograph taken by Voyager 1 is about 50 lakh bit size, which is about 0.6 megabytes. Now, if we look at it from today's standards, it is a very small size file. Whereas our normal smartphone's photograph also occupies a space of several megabytes. And the photograph of the black hole of the M87 galaxy was of 4 petabytes, i.e. 40 lakh gigabytes. But friends, with the help of technology in the 70s, it was not easy to send photographs of 0.6 megabytes from hundreds of millions of kilometers away. In its early years, when Voyager 1 was very close to Earth, its data transmission speed was about 1,15,000 bits per second. Now, with this speed, a photograph would reach the scientist sitting on Earth in just 43 seconds. But now, my friend, when it is 2,400 crore kilometers away from Earth, its data transmission rate is only about 160 bits, and it takes about 8 hours to send a photograph at this speed. Looking at the distance between Voyager 1 and Earth, this time is close to 21 hours. That is, if we want to receive a signal from Voyager 1 today, it will take 21 hours. And then, if the scientists on Earth send the answer to Voyager 1, it will take 21 hours again. But it is not necessary that as soon as Voyager 1 gets the image data, it will send it. Actually, there is a magnetic tape installed in it that saves this image data. And whenever the software thinks that communication can be easily done now, then it transmits this data. Now friends, no matter how advanced this camera system is, but it has been shut down in the 1990s. And the reason for this is fuel. Friends, in the 1990s, when it took the last photograph, it was already 600 crore kilometers away from the Earth. This distance is so much that the Earth looked like a small dot from there. Now scientists knew that this mission was going to go on for many years. And one day, it will come when Voyager 1 will reach the boundaries of the solar system and will also enter the interstellar medium. On August 25, 2012, Voyager 1 was the first object to do this. And friends, we got to know this because at that time, Voyager 1 was active. Actually, Voyager 1 had 3 radioisotope thermoelectric generators, or RTGs. Basically, the energy obtained from radioactive material is made into electricity. And then the functioning of the spacecraft runs with that electricity. Now, when it was launched, its power output used to be 470 watts. But the energy obtained from radioactive material decays with time. And that's why its power output is also decreasing by 4 watts per year. And today, it is producing only 249 watts per hour, which is 43% less than before. Now, the camera system of the Voyager 1 alone consumed about 42 watts of power. But apart from the camera, it also had 10 more scientific instruments. Now, if the essential instruments of the spacecraft had to be kept active, then there was no other option but to turn off the high-power consuming instruments in front of us, so that the other instruments do not have a shortage of storage memory. All the software related to the camera system was removed. It means that neither the camera of the Voyager 1 is on, nor the software exists that can capture the photograph from the camera and process it. And anyway, after enduring the harsh conditions and extreme heat of space for so many years, maybe they could have existed. But just imagine that if these cameras suddenly turn on today, what will happen in front of us? Well, friends, Voyager 1 has reached such a distance from the Earth that the sunlight reaches very little there. Now, if we take a photograph from the camera of Voyager 1 today, then we will see 1 or 2 big planets of the solar system and the sun shining in the sky, and nothing will be visible. Because apart from this, we will only see darkness all around us. That means there will be a dark sky in front of you in which nothing will happen. Now, an interesting thing here is that while living on Earth, we see the constellations of the distant sky just as Voyager 1 is 2,400 crore kilometers away. That is, if I see the M87 galaxy in the sky, then Voyager 1 must also be visible in the same direction. Because this distance on the scale of the universe is so small that it cannot create a considerable difference. If we want to see our sky from a different perspective, then maybe Voyager 1 will have to reach thousands of light years away. Now hopefully, one day it will definitely come when Voyager 1 will have reached so far from the Earth. But the sad thing is that by that day, neither I nor you are going to be alive, and neither the people of that time are going to see that scene from the eyes of Voyager 1. So friends, that's all for today. I hope, friends, that you have learned a lot of new things in today's video. And you must have found this video very informative. If you liked the video, please like it and share it with your friends. If you want to watch more interesting videos, subscribe to the channel and turn on the notification bell so that you can watch our videos first. Till then, bye.